this video, we'll be taking a look at organization structure, governance, and ethics. In particular, we'll be discussing their impact on information systems and information technology department in your organization. The content of this lecture is covered by Chapter 11, Structure, Governance, and Ethics, in your textbook, and as always, I highly suggest reading the chapter before watching the video. After you've completed the chapter and watched the video, there are a few recommended MyLab MIS homework activities you can attempt to test your knowledge, including the warm-up and video quizzes. Let's get into it and start by discussing the organization of your business's IT department. The organizational structure of IT departments and where they fit into an organization's hierarchy will vary from organization to organization. The size of a business, its culture, competitive environment, industry, and goals and objectives all play a role in determining its structure. For example, a manufacturing business that makes a physical product is going to have a very different view of IT and technology than a tech company who primarily provides a service over the internet. For a manufacturing company, IT is a supporting activity that keeps the lights on, so to speak. Whereas for a tech company, IT is critical to delivering their service to their customers. Because of these differences, we can't give one organizational structure that works for everyone. However, we can talk about it in general terms. As we discussed and read about in Chapter 10, the IT department fulfills two important roles. The first is IT operations, sometimes called IT services or information system services. Operations maintains the computing infrastructure for an organization, aids in enforcing technology-related policies, educates employees about security and information systems, and provides technical support to employees and possibly customers. These are the guys that you call up when you have technical problems. The second function of IT departments is developing IT projects. This group in the IT department is called IT projects, development, or development operations. And they do the planning, creating, developing, and upgrading of information systems. This could be through in-house developers and programmers, or by outsourcing the work to a third party. Both of these groups in the IT department are interconnected and have a cyclical nature, as we discussed in the Chapter 10 lecture. After projects creates an information system, operations has to maintain and support it. When there are problems start arising in the information system, or it needs to be renewed or upgraded, it goes back for further development by IT projects, and so on and so on. Here we have a typical organizational hierarchy. This is figure 11.1 from your text, and includes the top level of the reporting hierarchy, plus the IT department. If this is your business, you'd be at the top of the hierarchy, the Chief Executive Officer, or CEO. In publicly traded companies, a board of directors would be at the top, who represent the shareholders. Under the CEO, or sometimes the COO, would be the department heads, vice presidents, and corporate officers, including VP Marketing, VP Sales, VP Manufacturing, Chief Information Officer, or CIO, Chief Financial Officer, or CFO, and VP Engineering. So where does the IT department fit into all of this? Typically, the IT department reports to the Chief Information Officer, who's the head of the department and responsible for overseeing its activities. Within the IT department, we have a number of divisions, which may be a bit different depending on the size of the organization and its functions. As we've mentioned, operations handles maintaining the computing infrastructure and technical support. In this example, projects are split into a few separate entities. Development manages projects that acquire new information systems, which may be developed in-house. Outsourcing relations monitors development by external vendors and maintains good relationships with them if the information system is being developed by an outside entity or outsourced. The Chief Technology Officer, or CTO, heads the technology group and provides high-level guidance for future IT projects and monitors the impact of new technology. As organizations are becoming more data-driven, they may also separate data administration into its own entity or department. This group is responsible for managing and protecting an organization's data and establishing policies, practices, and standards relating to data management. Large organizations may also have a separate group for dealing with cybersecurity. As a real-life example, we can take a look at Western's organizational chart. Now, Western is a public university, so its organization is not typical, and it's very different than what you're going to see in business. But we can see the IT department in it still. Western calls their IT department Western Technology Services, or WTS. But this is a bit of a simplification, as Western is so big that individual departments and faculties may have their own IT departments. Within WTS, we can see the breakdown of different groups. Again, as Western is a university and quite large, their organizational structure is not typical. However, you can see the elements of some of the same groups, just more subdivided into specific roles. One quick note about the impact of the web on IT organizations. In the past, creating and maintaining the organization's website used to be a task of the IT department. This was due to the technical skill required, as well as the business not fully understanding the value of public-facing websites and the terms of marketing and customer relationships. With the advent of technologies like content management systems that make creating and maintaining the content of a website easier, this task has largely been moved to the marketing department, with IT only providing technical support. This makes sense, as the content of a business's public website is largely marketing related, and a lot of work needs to go into the design, branding, and messaging displayed on it. That falls outside of the expertise of the IT department. To give an example of this shift, this is what Microsoft's website used to look like in 1993. This is Pizza Hut in 1994. Interestingly, they were attempting to do online ordering even back then, in a limited form. And this is Apple Computers in 1997. This serves as a good example of how changing technology can impact the structure of an organization and the roles and responsibilities of the groups within it. Let's now move on to the topic of IT architecture. IT architecture is the basic framework for all computers, systems, and information management that supports an organization's services. You can think of this as like a city plan that lays out all the streets, water systems, emergency systems, power grids, and so on. This means you need a plan in place for how the information technology in your business will be designed, organized, and maintained. Not having a plan and just throwing in a new system on a whim is a recipe for disaster. The job role that's responsible for creating and managing this plan is enterprise architect. Enterprise architects create blueprints of an organization's information systems and plan out how they'll be managed and supported. It's critical for employees in these roles to understand the organization's current investment in technology and plan for the future changes. Technology is always evolving, and a business needs to have a plan in place for staying up to date with these changes. And this all ties into what we've been talking about through the whole course. Industry structures ties into Porter's 5 forces and determines competitive strategy. Competitive strategy ties into Porter's generic competitive strategies, and the one your business chooses helps determine its value chain. Your business's primary and supporting activities and functions in your value chain dictate the process and procedures your business uses. And these business processes impact what information systems you need and how they're designed. Taken all together, this is your enterprise architecture, and the enterprise architecture ensures that it all fits together and works together to accomplish your overall business goals and objectives. So with all that being said, how do you design your IT architecture? Well, unfortunately, there are few standards in this regard, as companies tend to be so diverse and different. This means that they each approach their business in a different way and in turn have different information technology needs. However, there is a framework for aiding in this process called the Zachman Framework. The Zachman Framework was developed in the 1980s at IBM by John Zachman as an architecture for information systems. This framework provides a formal and structured way of viewing and defining an enterprise by classifying it into 2 dimensions. The first dimension are the primitive interrogatives, what, how, where, who, when, and why, and the second dimension being the different stakeholder groups involved in the business. By stakeholder groups, I mean the different users of the system, as well as the groups that have some interest in the system's success. This looks like a 2D matrix or table with the what, how, where type questions as the columns, and the stakeholder groups as the rows. As you move to the right in the columns, you get different perspectives on the system. As you move to the bottom for the rows, you get more detail on the perspective as you get towards the end users of the system. This provides a template an organization can use by filling in each cell with its goals, rules, processes, materials, roles, locations, and events specifically required by the organization. Once completed, this table can be used to identify gaps in the organization's enterprise architecture and the documentation of its information systems. We could say this framework is the first step in understanding how our information system supports organizational objectives. And that brings us to alignment, which is just that, the process of matching our organizational objectives with our IT architecture. What this is asking is if your use of hardware and software and data actually support your business's goals and objectives. Does the software you use aid in accomplishing your goals? Does it make your company more effective and efficient than it would be without it? And by what amount? This is not a one-time process or a one-time question to ask, but one that is ongoing and continuous. Your business, technology, and the industry you exist in are in constant states of change, and you must always be reevaluating your IT architecture to ensure it continues to accomplish your goals. Alignment is measured as a degree by which your IT department's mission, objectives, and plans overlap with the overall business mission, objectives, and plan. More simply put, does your information technology help you do business? A good indicator of this is the level of communication between the business's executives and IT executives. Does upper management understand the benefits of IT and how it makes the company more effective and efficient? Or do they only view it as a cost center to be reduced if not eliminated? Effective alignment comes from the business culture that supports the sharing of knowledge and business perspectives between these two groups. Let's now move on to information system governance. What is governance? In terms of information systems and IT, it is the development of consistent, cohesive management policies and verifiable internal processes for IT and related services. This is a long way of saying that you need to develop policies for management of IT services that are consistent, always done in the same way, cohesive, meaning that they all fit together in a logical way to form a whole. These policies should address things such as sourcing, privacy, security, and internal IT investments. The overall goal is to improve or optimize the benefits of your business's IT investment over time, rather than having it simply be a cost center that only eats away at your overall margin. One way this is done is through reporting structures and review processes that can be established to improve the quality, reduce costs, and risks over time. A secondary important feature of information system governance is to ensure compliance with local laws. For example, Ontario has a Budget Measures Act, also called Bill 198, which requires publicly traded companies to track, report on, and disclose certain financial information that must be recorded by the business. This is important for information systems that deal with an organization's accounting and financial data, as they must be in compliance with the Act, have proper and reliable financial controls, and the reported information must be auditable. Management must be able to show that accounting information systems used by the company have appropriate controls and that unauthorized access to sensitive information is prevented. If they can't, both management and the business might be subject to financial and criminal liability. The second law of concern in Canada is PIEDA, which governs sharing of individuals' private information. We'll talk more about this in our lecture on security and privacy, which you'll also read about in Chapter 12. And that brings us to the topic of information system audits. You might be familiar with the idea of a financial audit, where a company's financial records are examined by an objective third party for compliance with laws and ensuring that they're fair and accurate. An information audit is a similar idea, but for information systems. It is an examination and verification of a company's information resources that are used to collect, store, process, and retrieve information. This can also include the organization's policies and procedures pertaining to the information system in question. In particular, these kinds of audits focus on information system resources used to collect, store, process, and refine information, and the controls that are put in place to ensure it's accurate. Security audits are also a specific kind of IS audit that concentrates on finding potential security flaws, exploits, vulnerabilities, and weaknesses in both technology and procedures used in an information system. More responsibility is also placed on senior management, as they're required to make assertions about the controls on their information systems that may expose them to increased liability. This means that senior management could be in a lot of trouble if a security incident happens, or financials are reported incorrectly, and it was found that management did not make every reasonable effort to prevent this. This includes not only financial penalties, but possibly criminal penalties, such as jail time in extreme cases. Simply saying you didn't know about the issue is not going to cut it, and this is why audits by third parties are so important. Our last topic of the lecture will be information system ethics. Information system ethics primarily involves the people involved with your information system, but not the hardware or software components. Is their use of the system ethical? But what is ethical? That can be subjective and hard to define. But there are some sources of guidance. A big one are the local laws of your country, province, and municipality that you're located in. If your use of the information system is legal, you can be pretty sure that it's not ethical. Another source might be the information system's acceptable usage policy that you sign or agree to as an employee of the business. Most organizations will have rules for how you may use their technology infrastructure, and not following this agreement would likely fall into unethical use. For example, Western has acceptable use agreements that govern the use of its computing resources, that all users must read and agree to, including all faculty, staff, and students. This includes things like not using resources to break the law, not sharing your account with others, not monopolizing resources in a way that would prevent others from using them, limiting use to non-commercial activity, not altering or manipulating other users' files, and not otherwise abusing the system. Why should you care about this? Well, acceptable usage agreements like this come with penalties for violating them, such as the loss of your account. Even if you don't care about ethics, that could be a big deal for you as a student if you can no longer submit coursework or access OWL. In a business environment, not following this agreement could mean simply being fired. Other sources of ethical guidelines may come from governmental organizations, such as the UN or the Canadian Charter of Rights and Freedoms, or professional associations such as the ACM. Regardless of where they come from, ethics involve understanding our behavior and the way we think about and act in situations where our choices impact others. Let's take a look now at one particular movement in the IT industry to deal with an ethical concern, and that is green IT. Green IT, or green computing, means using IT resources to better support the triple bottom line of organizations. The triple bottom line includes measures of traditional profit, along with ecological concerns and social performance. The idea here is not to solely care about profits or financial benefits, but also the impact your organization's decisions will have on the environment and society as a whole. There are many elements of green IT, but its primary goals are to improve energy efficiency, promote recyclability, and reduce the use of materials that are hazardous to the environment. Green IT, therefore, represents a choice to consider not only the financial implications of adopting and using IT, but also the effects of those choices on people and the environment. A great example of this conflict between a new technology and the triple bottom line is cryptocurrency mining. Generating or mining cryptocurrency takes a massive amount of computing power and energy. In fact, the Cambridge Bitcoin Electricity Consumption Index, a tool created by researchers at the University of Cambridge, estimates that the current energy use of Bitcoin is higher than the total energy use of the Netherlands, and this is a conservative estimate. On the worst case, it could be as high as Canada's total energy consumption, and this is just for one cryptocurrency, Bitcoin. There are many more, like Ethereum. So the last thing I'll leave you with is this question. In the age of global warming and climate change, is Bitcoin worth it? What real value does humanity get from Bitcoin, and is it worth destroying our environment for? Sorry to leave off on that depressing note, but that's all I have for you in this lecture. Thank you for watching, and have a great day.